Well, hi and welcome everyone. Thank you so much for being here today. My name is Katie Chakowski and I'm a Special Collections Librarian at the Portsmouth Public Library in New Hampshire. I use she, her pronouns. Also joining us is Nicole Luongo-Cloutier, who is the Head of Reference and Special Collections. And I'd like to begin tonight with our land acknowledgement. The city of Portsmouth is on the homelands of the Abenaki people who have ongoing cultural and spiritual connections to this area. According to tribal oral tradition, Abenaki have lived in the place now called New Hampshire for more than 12,000 years, since before tribal memory. The Abenaki are part of a larger group of indigenous people who call themselves Wabanaki, or People of the Dawn, and form one of many communities connected by a common language family. Here at the Portsmouth Public Library, we are committed to acknowledging and honoring the human history tied to this land. Tonight's event will last until 8:30, and we plan to be respectful of your time. We've turned on subtitles for this event. If you prefer not to see them, you can hit hide subtitle, which is an option at the bottom of your Zoom window. We are recording today's event, and that video will be available on our YouTube channel in a few days. And you're welcome to leave your video on, but we ask that you keep yourselves muted during the talk. And if you have any questions, feel free to put those in the chat and we can read them out loud at the end of the presentation. Or you can also save your questions for the end and ask them out loud. And tonight's event is part of our local history series. We host these monthly, and the next one will be on Tuesday, May 10th at 7 p.m. We'll be joined by John Mayer, who has worked in museums for over 30 years. He'll be talking through discovering the history of your house using local resources to illustrate the process. This will be both in person at the library and online via Zoom, and registration is required. I'll put the link for that in the chat. Our Special Collections Department also hosts another monthly program, our genealogy workshops, the next of which will be on Sunday, May 15th at 2 p.m. with Jill Morelli, who will present Write As You Go, a methodology for efficient genealogical report writing. This one will be on Zoom only, as our presenter lives clear across the country, and you can register in our library calendar, and I will provide that link as well. And we love hearing from you about what you'd like to see at the library. So I'll share an online event feedback form, and if you fill it out, you'll help the library and you will be entered to win a library book bag. And this contest is only open to those who can visit the library and pick up the prize in person. So thank you all for joining us tonight. Again, we at the library, for those who don't know, have a set of core values, which are on our website if you're curious, excuse me. But one of those values is a commitment to preserving and sharing local history, and another is a commitment to sustainability. So this talk really piqued both of our interests. As a community built along the water's edge, the local climate system is something we think about regularly. So we're really excited to hear about the history of Mount Tambora and its effects on us here in New Hampshire. So let me introduce you to our speaker, Will Broussard.
You got it.
Awesome. He's the former outreach coordinator for the Mount Washington Observatory, where he developed educational programming around Mount Washington's unique cultural, scientific, and ecological history. Currently, he serves on the board of the Tin Mountain Conservation Center and is program coordinator for the Mid-Coast Audubon Society of Maine. When not pursuing his environmental conservation interests, he harvests and ships mushrooms from North Spore Mushroom Company in Portland, Maine. So with that, Will, I'm going to turn it over to you.
Great. Thank you, Katie. Thank you all for connecting with us today. Thank you to the Portsmouth Public Library. I know I'm competing with some really beautiful weather, so I don't mind that some folks will have to just wait and see the recording later on. So I wanted to begin tonight's talk by mentioning something that happened 88 years ago in the state of New Hampshire at my former place of work, the Mount Washington Observatory, because today is the day that we celebrate Big Wind Day on Mount Washington and at the observatory atop Mount Washington. So it was on this day, 88 years ago, at roughly 1:20 in the afternoon that a very small group of weather observers living and working on the summit of Mount Washington recorded the highest wind speed ever recorded directly by a human being. And that was 231 miles an hour from the southeast. Pretty incredible wind gust. A higher wind was recorded off the western coast of Australia in 1996, 253, associated with the cyclone, what we would call hurricane, and that wind was actually recorded from an anemometer. So there weren't people there. They had to actually evacuate the location. But to this day, Mount Washington's weather station gets the gold medal for having observed directly the highest wind on the surface of our planet. So that's pretty exciting. So happy Big Wind Day. All right, so let's turn to tonight's presentation. We'll do our screen share here. And we'll see if we got that up. All righty. So 1860, in the year without a summer, is a fascinating history, a global history of one particular event that took place, that actually took place in 1815, the eruption of Mount Tambora in Indonesia. It was a pretty large volcano, about kind of similar to the volcanoes we have on the western side of the United States, the ones out in Oregon and Washington in terms of its height. But this particular volcano really changed the world during and after its eruption. So we'll get into that. All right, so some highlights. Where Mount Tambora is located. It's located in the Lesser Sunda Islands of Indonesia. I'll show us a map in just a moment. The eruption date was April 10th, 1815, so just a little over 207 years ago. And it's an important event because it is the largest observed eruption in recorded history. It unfortunately had a massive death toll of nearly, and many researchers say over 100,000 people died in direct relationship to this this volcanic eruption. Sadly, a number of people died on the island pretty much in the first 10 minutes of this eruption. An entire basically culture, an entire civilization, the Tambora culture, was wiped out following the immediate aftermath of this eruption. And of course, it led to the global cooling event that we call the Year Without a Summer in northeastern North America, but there were effects all over the Northern Hemisphere, especially with some lasting historic, scientific, and cultural influence. So we're going to just get into some definitions here, because it might have been a while. It certainly was for me a while since I had learned about volcanoes. So it's a bit of a getting back to our roots here with some basic definitions. So the volcano is a rupture in the crust of a planetary mass object, such as Earth, that allows lava, ash, and gas to escape from a magma chamber. They're generally found along fault lines where Earth's major tectonic plates are pulling apart, coming together, or sliding aside. And they can be active, dormant, or extinct volcanoes. So here's a map of the world's tectonic plates, and where they come together, you'll see this is where we have a series of pretty intensive natural disasters going on from time to time, and many of our volcanoes are found here. The famous Ring of Fire along the kind of the outline of the Pacific Ocean, you can see there. And if you go down to just above Australia, where the Indo-Pacific Plate meets the Eurasian Plate, that is where we're going to be talking about. So right there. So zooming right in on that, you'll see kind of center right in the image, that is the island of Sumbawa, and that on the northeast side of that island is the former location of Mount Tambora. So you can see Mount Tambora is in a location that's very active volcanically. You can see many other islands, including far west of Java, where Krakatoa is, another famous volcano. So this is a neighborhood that's very active. And you can see that according to the little key there, many active volcanoes, and then there are some really large volcanoes that have erupted in the last 2,000 years. So again, very active. Looking kind of below the Earth's surface at this point, you'll see where what's called the Indo-Australian Plate is actually coming together and diving below the Eurasian Plate. So that really causes a lot of pressure to build up and a lot of friction that happens that can lead to some of these very explosive volcanoes. All right, some other volcanoes that we have. So we talked about Tambora as being a particular kind of volcano. We'll get to that. There are many kinds of volcanoes. One could call them species of volcanoes that we can learn about here. So the most famous is the composite, or what's called the stratovolcano, which Tambora is one of, along with Mount Vesuvius and Mount Fuji, Mount St. Helens. These are some of those that erupt the most violently. And they're formed through the millennia by layers of solid lava flows that are then kind of overtopped by sand and gravel, like volcanic rock, cinders, and ash. So over time, multiple layers will form on these types of volcanoes, and that does play into why they can be so violent. Some other volcanoes we have include the shield volcano, which are very broad and have a low slope. They have actually they're the kind of volcano that created the Hawaiian Islands. So they're actually not as explosive, but they can be very active. They can continuously erupt kind of gooey magma or lava, I should say, that just slowly builds these islands. Mauna Loa and Mauna Kea in Hawaii are great examples of these. And then the cinder cone volcano, they might not be the most famous in terms of if you've heard of them or not, but they're the most famous in terms of what you might see in a child's drawing. You know, this is very loose, grainy cinders, little to no lava. It's kind of the steepest, it's just classic volcano in terms of what it looks like. So there are a number of these all over the world, including some in Mexico. So I mentioned just a little bit about the kinds of products that come out of these volcanoes. Well, eruptions themselves have a classification system, and we can go over that. So eruptions can be effusive or explosive. So effusive is more like the Hawaiian Islands, where lava flows like thick, sticky liquid, and it's just kind of slowly over time, versus explosive, where you might have pressure build up over time and a huge explosion with a lot of consequences for people and wildlife and landscapes around those locations. There are different kinds of eruptions named for different volcanoes. So it's actually kind of funny. We'll get into it in just a minute, but I wanted to show you the left side of the image here. We have Mauna Loa with that more effusive eruption on a shield volcano, and then Mount Redoubt in Alaska with more of that classic shield explosive type of volcanic eruption. So as I mentioned, there are different eruptions classified by the products that come out of them and out of the eruption, but also by the name of the location that they're kind of most famous for. So for instance, the Hawaiian eruption up in the left side here, these have what's called fire fountaining, just incredible ongoing lava coming out of the ground. Again, not as explosive, but very continuous. And you can go to Hawaii and see some of these lava fountains. Kind of moving up the chain here, we have the Strombolian eruption. This can be short bursts of lava that might come out, come out of the ground there. And for instance, Stromboli is a volcano in Italy, and so they named this particular eruption for that. Moving upwards, something called the Circean eruption. These are often associated with undersea volcanoes, where you actually have an explosion that is something that happens where the lava is interacting with salt water, and you get basically an explosion below water. And many islands, or many volcanoes in Iceland, are of this variety. There's also the lava dome, such as the center of Mount St. Helens, where you have very sticky, cooler lava that just kind of hardens in place, and they might grow and collapse in cycles. And you have you might have some big eruptions from this particular kind. Again, moving up the chain here, up the ladder, to something called the Volcanian eruption. This can have more violent eruptions that create big columns of ash and gas, and occasional flows of ash and cloud that come down the sides of the mountains. Again, as we're moving up this kind of scale here, we're going from eruptions that happen very often and are very low in terms of their impact, to eruptions that happen very infrequently and are very destructive. Because if you think about what's going on here, you've got lava coming out of the earth. That's essentially, it's kind of like putting your thumb over a garden hose and having the pressure build up. You know, if you have a ton of pressure building up on that hose, you're going to have, eventually you're going to have the hose burst and an eruption happen. Versus the Hawaiian type volcano, which it's constantly kind of coming out, and you're actually you're not going to have that pressure buildup. So to the right here, you have the Plinian eruption, and this is the largest and most violent of all. And you have all kinds of heavy material that come out during this kind of eruption, which is very infrequently in time, but very devastating with widespread consequences. Mount St. Helens in 1980 had a big eruption. Mount St. Helens is kind of the classic famous American volcano that we know of, that has this kind of huge ash cloud, lots of material coming down the sides of the mountain, that sort of thing. And Mount Tambora was very much so of the Plinian eruption variety. So alongside this classification of eruptions, you have classification of volcanic explosivity. So you have an index, the VEI index, and this is kind of based on not just the destruction of the volcano, but actually the volcano, meaning the destruction that the volcano wreaks on the world around it, but you're also kind of classifying the types of products that come out of the volcano. So you can see in the VEI index on the right-hand side, you have, you know, a non-explosive volcanic eruption of Mount St. Helens in October 2004. So you have the amount of material, or tephra, that come out of the volcano to be very little, going all the way down to the largest kind of volcanic eruption, where you have huge amounts of material that come out. And with that, you also have just larger pieces of material. So you get 0 to 8, so 0 being non-explosive, and very large explosions, because there are usually multiple explosions that happen with these larger eruptions. So Tambora is at the top. It had a very large explosion between 6 and 7 on the Volcanic Exclusivity Index. So I just want to get folks understanding that this was a pretty unique explosive event. If you look at this image here, again, it's the really great examples of different different volcanic eruptions that happen through time, and their volcanic explosivity index clearly demonstrated. So you have at 7, you have some other really large volcanoes that went off, many of them a long time ago. So you can see back to where we were talking about how the largest volcanic eruptions happen very infrequently, on the order of 1 every 1,000 or every 2,000 years. So it's not likely that you would necessarily experience one yourself, but if you go through time, 1 to 2,000 years, you're likely to get something like this. Just an image again, comparing and contrasting some of these. The Yellowstone volcanic eruption, which happened 500,000 years ago, had an incredible amount of material ejected, and this is talking about cubic miles of land that was essentially converted into cloud. So Yellowstone is 300, and Tambora is 19 to 20. So really a lot of landscape. So and to kind of go back to that, just to mention it, enough land, in fact, that you could cover New England with 1 foot of ash, all of New England, with the amount of material that came out of this volcano. So the eruption itself of Mount Tambora, the main eruption was in early April of 1815, but the eruption, it's kind of started a couple years earlier. So rumblings started out a while earlier, but the major eruption happened from April 5th to April 12th. And it was incredible. Unfortunately, as I mentioned, the Tambora culture, some 10,000 people with their own customs, their own history, were wiped out in minutes of this eruption happening. Obviously there weren't really ways to capture what it looked like, so I grabbed this particular kind of imagination of the destruction of Pompeii, painted in 1822. So volcanoes are in the minds of our historians, and certainly the story of Mount Vesuvius was well known, in history. And so that kind of was what the Europeans and others who kind of thought about volcanic eruptions really imagined when they thought about any particular kind. They think about the eruption of Mount Vesuvius. So I mean, it certainly well could have been like that. Explosions from Mount Tambora were heard 1,600 miles away. Ash fell 800 miles away. So an incredible amount of damage immediately. Those who survived the initial eruption had to deal with disease, crop failure, ash contaminated water supplies. They say that the energy release was equivalent to 33 billion tons of TNT. So that's like several nuclear bombs worth of energy released. The Indonesian archipelago at this time was very much under the control of the Dutch, and with some incursions from the English, and so there was a lot of warring going on. This is also towards the end of Napoleonic Wars in England, or in Europe, and so everyone was very kind of trigger happy, and so there were actually groups of soldiers that were basically told, we're hearing war breaking out. We need to get ready. And so you could essentially imagine that the sound of this event, it sounded like gunfire. It sounded like black powder explosions, and you could hear it so far away. So it's not hard to believe that people thought that there was a war going on. And much of what we know comes from journals of folks stationed in Indonesia, that we get a lot of this information. So immediate effects with any explosive volcano, you've got Tephra fall. So Tephra is any solid that comes out of a volcano during an eruption. And so you have a number of different kinds of tephra. You have ash, the smallest kind, and that covered, that was as deep as 5 feet in some places on and around Tambora. But even, you know, even just the next island over would have feet of ash, which is incredible. You had cinder blocks, bombs, pumice, acid rain, all different kinds of products that come out of these things that are really, you know, not really compatible with life. Just incredibly dangerous situation. You have pyroclastic flows, which are gas, dust, and magma avalanches that come down the mountain. They had 13-foot tsunamis that happened kind of all around where the pyroclastic flows hit the ocean and displaced so much water that you had, you know, other islands getting hit with these waves, these massive waves, just from the material coming out of the volcano, and volcanic lightning on top of that. So just incredible. I wanted to show a short video if it's possible. Okay, so I'm gonna just redo this just for a second, just to show us when a volcano erupts, how quickly the material from the volcano moves around the earth. And I should say the material that is light enough to be carried by the winds. So this is from Mount Pinatubo, and this is a model. So this is actually a scientific kind of guess using weather patterns and using air currents, modeled out what kind of one particular cloud of ash how it would behave immediately upon entering the atmosphere. So I want to share this with you. We can play it a couple times just so you can watch what this does. It's very fascinating how ash behaves in the atmosphere. So this comes out of, in particular, Pinatubo, which is a bit further north of Tambora. But you can see how quickly the ash goes around the planet.
Well, I don't think we're seeing the video. We're still just seeing like a still shot.
Oh, okay. And are you seeing the a map of? Oh, okay.
No.
All right. Let me do new share. Oh, here we go. I'm going to try this. I'm going to share this now. Can you see that?
Yes.
Okay,
yep.
perfect. Thank you.
Thanks.
So I'll share with you one more time, kind of a scientific rendering of what happens to ash as it enters the atmosphere. So it quickly covers all of planet Earth. And I'll play it again since we only got to see it once. But you can see that ash quickly goes around the equator, but then it gets caught up in the north and southern hemispheres. So I'll play it one more time. And you can really get to see how an eruption in one part of the Earth can have an impact, if nothing else than just through its ash cloud over planet Earth. So really fascinating. So if you look up Mount Pinatubo particle model, that is how where you'll find it. So go back to Tambora. Okay. So this particular ash cloud is what Tambora could have looked like. This is from a volcano in Indonesia. So the video that I shared with you of Pinatubo particle kind of model of the clouds, the ash clouds moving around the Earth. Think of that when you think of how ash from Tambora's volcano could have gone all over the world, but also had such a long-lasting impact because that ash wasn't just, you know, dumped into the air above uh, uh, these islands. It was sent up into the atmosphere. So it was sent up into the stratosphere, which is the layer of atmosphere that sits above the troposphere. And the troposphere is where you and I live. It's where clouds form. It's where our weather happens. So if you have material that's injected into the area above that, that stays around for a long time. So it's really interesting. And ash itself contains a bunch of particles, the major players being sulfur, that actually reflect incoming radiation from the sun, and they send it back into outer space. Therefore, the lower level, the troposphere, doesn't warm up. It actually starts to cool down. And this particular volcanic eruption, Tambora, resulted in 5.5-degree drop in temperatures throughout the world throughout 1816. And it doesn't seem like much, but that is absolutely enough to have the weather be very wacky. And we'll talk a bit about that. So this is a great schematic from The Economist that shows us kind of over time how an eruption might impact us. Of course, in the immediate aftermath, you have things like I mentioned, the pyroclastic flows and tsunamis in the course of hours and days. But then you start to have the ash that falls, and then you might have, in a modern sense, you might have something like global supply chain disrupted, and airlines rerouted. And that actually happened about 12 years ago in Europe, when a volcano in Iceland erupted and continued to erupt for some time. And it actually did affect the global supply chain, in a sense, at least regional supply chain and regional flights. And then in the time scale of years, you can have that reflection of the incoming solar radiation, which cools the planet. So what this brings us to is the change in our weather and the short-term change in our climate that took place following the 1815 eruption of Mount Tambora. So under a normal regime, our weather, all of Earth's weather, is powered by an uneven heating of the Earth's surface and atmosphere. So as the Earth rotates around the sun sends its rays most directly at the equator of Earth. That's why it's warmest at the equator. So because the Earth is rotating, though, that heat that's at the equator has to go somewhere, and it wants to dissipate back out into space. But because Earth is rotating, that heat is deflected towards the north and south poles, and that actually helps to create our weather and climate. But what happened under the Tambora regime, following that massive eruption, you have, in a sense, an uneven input. You have basically a globe that's covered in white paper that's sending that heat back out towards space. So you just have a much colder Earth. And so that created kind of a supercharged heating situation where the sun's heat at the kind of the top of the atmosphere, up in the stratosphere, it can actually warm it up quite a bit, while the underlying troposphere stayed pretty cold. And so in Earth's attempts to kind of balance that heat out, you get something called the negative phase of the Arctic oscillation. So in this situation, so let's look at the first image here of Earth. So what we're looking at is the jet stream on planet Earth, on the Northern Hemisphere. The jet stream is a river of air that's always kind of floating around the Northern Hemisphere. And you have storms moving along the jet stream. The jet stream pushes these storms around. And in a normal positive phase of the Arctic oscillation, you would have a stronger jet stream that keeps that cold air locked higher up latitude-wise, higher up towards the poles. But what happened during the Tambora period is that you had the negative phase of the Arctic oscillation, which led to a very wavy polar vortex, very wavy jet stream. And it allowed a lot of these cold air outbreaks to come down towards the equator. You just had a lot more cold air to work with. And this led to it not just being colder, but it being actually more stormy in other parts of the world. So you had excessive rainfall in some locations and excessive snowfall in others. So some global impacts resulting from this were latitude dependent. The Northern Hemisphere has a bit more land mass than the Southern Hemisphere. And so you're going to have a lot more kind of weather impacts in places that just have a lot more land. You have the greatest influence on Northern Europe, Asia, and parts of North America as well. You had increases in precipitation in Europe, and we know this from, different folks keeping different journals, again, keeping records of what was going on then. We knew that there was a drought, a very bad drought in Southeast Asia, and even in parts of Eastern North America as well, and generally cooler worldwide with some historic impacts related to that. So in Europe, they saw unseasonably cold and wet weather in the spring, summer, fall of 1816. Because of this, I'd said here colorful sunsets, and that was related to the to all that particulate matter in the atmosphere. But again, because of this unseasonable cold and wet weather, you had crop failures throughout Europe. Again, this was also towards the end of the Napoleonic Wars, so already the population was taxed and not doing well. And so this was not something that was very helpful that happened on top of that. So you had outbreaks of different diseases throughout Europe and in other parts of the world, which we'll talk about. There were, however, some advances in different sciences that were very fascinating. There seemed to be a lowering amount of sea ice at times in the summer of 1816, allowing for some much further north travel and exploration, which was interesting because of the cold air that kind of came over Europe. There were actually instances of glacial formation, or at least glacial reformation, where glaciers were perhaps retreating or just not doing much. During 1816, there were visible changes in glaciers. That is, they grew in parts of Europe. So that led to some advances in the study of glaciology, which is really interesting, and meteorology too, because the weather was kind of going kind of wild. And so you had more people noticing that the sky looked really strange, that the sky looked colorful, more people kind of taking an interest in that kind of art, so taking more interest in preserving for all time pieces of art that would show us what the sky looked like back then. Just more interest in that, and then some changes brought upon by the bad weather in Gothic literature, which we'll talk about. Talking about meteorology, again, you can see in the images from this time, not just the beautiful sunsets, but the stormy weather. There was a gentleman, Luke Howard, who was an English chemist and meteorologist, who classified he used an earlier classification system for clouds to add on that, and he created kind of the first essay on clouds earlier in the 1800s, but he basically used some of this more interesting weather to create the first climate of London compendium from 1818 to 1820. So he took, daily observations of wind direction, air pressure, temperature, rainfall during this time. So there was just an increased interest in the atmosphere. So very interesting kind of changes spurred on by this particular event. In Germany, an individual named Karl Drais, he was an inventor, and this was a time, again, following the devastation of the Napoleonic Wars and widespread crop failure and food shortages. The main mode of transportation was the horse, and so a lot of people had to resort to eating horses, or just weren't able to feed their horses because there wasn't enough food for them. And so there was this pressure to kind of come up with a new mode of transportation. And so the very earliest bicycle came from this time period, a two-wheeled human-powered vehicle, 1817, that didn't quite look like a horse, but was used in place of a horse to get around. So really interesting, innovations going on during this time of real scarcity, of life. Kind of moving a little bit east, or south, I should say. This gentleman, Venets, it was Swiss, he studied all kinds of things, but he was the state engineer for the region of Valais, and he actually was involved, as I mentioned earlier, with a particular glacier that advanced and basically got in the way of a river that was flowing and formed a glacial lake behind it. And so it was feared that this particular glacial lake would at some point explode out from this this glacier that you can see in the lower right. And so he did his best with some other people in this area to try to get that glacier moved, but in the end there wasn't an issue. It kind of resolved itself. But this attention being paid to this rapid movement of a glacier allowed him to start to think about, well, if you think about this time, this is prior to many of the, let's say, the modern theories of evolution, for instance. Many people at this time believed that the Earth was created much sooner, closer to 5,000 to 6,000 years ago. So people didn't really believe that the Earth changed through time. And so seeing these glaciers move and connecting the dots by looking at, for instance, giant boulders that were kind of along the edges of some of these valleys where these glaciers were forming, allowed him to start to come up with ideas around glaciation, which people didn't really think about at all. The idea of giant, rivers of ice moving through your town and kind of changing everything. So that was really interesting, that came about as well. So I mentioned Gothic literature. So again, in Europe, we had, such terrible weather in the summer of 1816, that, some of the cool people that were around at the time, the poets, Mary Shelley and her spouse, Percy Shelley, and a number of folks that they were hanging out with happened to be in Italy with some bad weather, and they were kept indoors. They wanted to go out sailing, but they couldn't on Lake Geneva because of this bad weather. And so they came up with basically a competition to write the best ghost story or write the best scary story. And two really famous stories came out of this particular instance. One is Frankenstein, written by Mary Shelley, and the other which was written by Lord Byron's physician, John Polidori. That was called The Vampire. So it was one of the first, both of these are one of the first kind of instances of this particular, you could call them meme, this particular instance of this kind of monster coming out of just being stuck inside and not having a whole lot to do. Of course, they were poets and writers, so they had a lot of, you know, talent in that way, but it was the bad weather that really forced them in and thinking about these kind of darker themes. So it's really fascinating that it was that it led to this kind of literature, particular literature. So further east, you had some really negative impacts in Asia relating to adverse weather conditions brought on by the Tambora eruption. So similar to Europe, crop failure happened throughout parts of Asia, China, Taiwan. You had, you know, parts in this particular part of Asia, you had a lot of rice production, which definitely was failing during this time. And so you had actually a slow movement, which then kind of, you know, got larger and larger to replace rice with opium. And that had, you know, pretty large impacts down the line. But it really was brought on the, you know, this need to bring in a different product, a different crop was brought on by this this adverse weather. And the monsoon in India, which is kind of a late summer heavy rain event that happens every year, this was severely delayed by the adverse weather conditions brought on by the Tambora eruption. And so you actually had a major cholera outbreak that happened in 1817 in India, which spread across the globe. So kind of to dive into both of these locations. So in southern China, Yunnan province, long history of rice production, and then the sustained rainfall, cold temperatures, and even some summer snowfall, which we had in New England as well, led to just a devastation in the harvest. And within just a few years of nearly complete replacement of that crop to opium, which I didn't know about this until I did some research on it, and it just fascinates me. And then India, you have the cholera bacteria that normally lives basically in salt marshes, that due to the delayed monsoon, they say it was, you know, because there wasn't enough kind of fresh water falling from the sky, you had some areas along the coastline that became hyper saline, very salty, from kind of drying up of some of these salt marshes, that you had essentially like a superbug of cholera that came out of the Bay of Bengal, of Northeast India. And so you had a global pandemic that came out of this, wherein cholera spread along trade routes to different parts of the world. And you can see these images of Earth. You have basically the pandemic spreading, you know, and it even reached the United States in the 1830s. And then you actually had some state-sponsored health engagement where you had governments of different countries, namely Britain, kind of intervening and saying, well, we need to step in and figure things out here. And so you had boards of health, and then the International Sanitary Conference, the first that focused on cholera in 1851. So some real changes in society, at least in small pockets, coming from this this one event. So North America, where we live, had a lot of adverse effects as well. Crop failure throughout New England, in particular, northern New England, having killing frosts every month of the growing season. So you had no crops, and there were stories that I've heard that, there were towns in New Hampshire that were fueled by one farm that happened to have planted all of its crops on, on the south side of the hill that they lived on or something, and had just enough solar energy to warm up the ground to get, enough food to feed themselves and their friends and their town. So just some devastating effects from the mid-Atlantic up into New England. And because this was happening, there was mass migration that happened. You had New England states having decreases in population, during this period, whereas just 10 years before, you had these locations, these areas getting more populated. But the Tambora period was kind of a net loss of people, and in fact led to the states of Indiana and Illinois being brought on board in the young America, because you had people moving to warmer, more agrarian parts of the United States. So you actually had mass migration of New Englanders to parts of the upper Midwest. And also in New England, we shifted from, as I write here, we shifted from riparian to marine fisheries. So this really means we went from really going after some of the fish that go up our rivers to getting fish that were further out to sea. So we moved to a less desirable fish, the mackerel, during this time. That's why they also call it the Mackerel Year. So that was a change that was brought about by the Tambora period. In the records, we have a storm, a spring storm, late spring storm, June 6th, 1816, that brought snow, kind of like the storm of the century that many of us remember, brought an incredible amount of snowfall to northeastern United States, with just some apocalyptic scenes, with not just crops failing, but birds falling from the sky. There's a note that I read where farmers thought that their sheep were going to freeze to death, so they wrapped their shorn sheep back up with their wool. So just incredible amounts of cold that came about throughout the entire summer of 1816. So, it wasn't necessarily that every single day in the summer of 1816 was below freezing, but there was just enough killing frost. So temperatures below freezing for just, a few hours a day can kill some of these sensitive plants, so crop plants. So there was just enough cold air around to really devastate the crops in New England during this time. Of course, this period was celebrated, it's still celebrated and well known. Going back to June 5th, 1907, a magazine, kind of a satirical magazine, came out with this cartoon showing what the Tambora summer was like. So they have, in the middle picture, people are trying to heat up the ocean so that people can go swimming in the middle of the summer. You have, a really kind of, unlikely scenario on the lower right, where people are just out doing their business and they come across walruses, because apparently walruses are a sign of the Arctic. But so even, for many decades, this period was well known as a time of incredibly strange weather, incredible devastation in different sectors of the economy and of our lives. So scientists today, going back for the last 30, 40 years, have been using ice cores to really understand the past weather of Earth. You can go to Greenland or Antarctica and dig really deep, you know, half a mile long ice cores that are incredible pictures of past weather and climate. They're basically able to take the air bubbles, the tiniest air bubbles um, out of these ice cores, and take the air that was preserved when that snow fell, and actually by kind of taking the different molecules of carbon dioxide, oxygen, other components of the air, and basically correlating that with average temperature of the atmosphere at that point of snow deposit on the ground. So scientists are still doing this today and doing amazing work in reconstructing past climates. You know, they do this not just through ice cores, but also using pollen grains, tree ring data. But it really kind of took off in the mid to late 1960s. And not only are they able to reconstruct past temperature profiles, but they can also look at ash and sulfur deposits along those ice cores, and you can actually kind of get a sense for where and when the volcanic activity was really great, including at Tambora. And so this particular image here, we have kind of a showing back to uh, thousands of years, tens of thousands of years, seeing the kind of warm and cold periods. And you can actually see that there was what's called the Little Ice Age around the time of the Tambora eruption. And that's actually because Tambora wasn't the only volcano erupting at this time. There were a number of other volcanoes that weren't exactly recorded, perhaps because they were in more remote locations. But there was enough volcanic activity around this time that generally for 500 years or so, you had a cold, colder than average. So it's just an important kind of image just to understand that, yes, Earth's temperature changes through time, and we can see that through ice core data. And now I think we've reconstructed back at least 1,000,000 years through various means to understand what the temperature swings were like. So it's really fascinating to be able to add that Tambora period to this much longer period of time. So as I mentioned, we looked at that the Pinatubo particle model. There are supercomputers that allow us to understand how ash might behave in the atmosphere, how following volcanic eruption leads to changes in climate. It's really fascinating how one event can have such a global impact. And we're still learning a lot about it. So paleoclimatology is the study of past climate, and much of it we are learning about through ice cores, but also through these massive events like volcanic eruptions. And I want to wrap this up with a card that a friend sent to me, a fan of Mount Washington back when I worked there, who drew this beautiful, what looks like a cinder cone volcano, basically talking and saying, don't worry, I'm a mountain, not a volcano. Volcanoes are mountains, but he's right. Mount Washington is a mountain made of material that's not volcanic. So we don't need to worry about Mount Washington erupting anytime soon. And So with that, I'll leave us with some references. Much of what I learned about the Tambora period I got from this book, Tambora, The Eruption That Changed the World by Gillen Darcy Wood. And this was really helpful. Anyone who wants any of these links, we can set up a way to contact each other, because there's a lot of information out there about 1816, Year Without a Summer. Lots of town records too that I encourage you all, if you're interested in, you know, how particular towns in New Hampshire, Maine responded to this time. You can get some of that information to learn about, you know, how different places reacted differently and how they kind of struggled through this period, because it's just fascinating. So with that, I'd love to take any questions. I think perhaps Katie, if do we want us to come back to a I can drop the screen share, I mean, if you want.
Sure. Yeah, and if anyone has any questions, feel free to put them in the chat, or you're welcome to unmute yourselves and ask any questions out loud. And I did just put the link to Tambora, the book, in the chat. We do have that book in our catalog, and you can put it on hold.
Great.
Any questions from anyone? That was a lot of information, Will. I think people are absorbing. Oh, Tom's got a question in the chat. Can Tambora be excavated like Pompeii?
Yes, actually, I believe a lot of what was learned about the Tambora culture was actually unearthed at Tambora over the last 50 or so years. So yes, I believe it can be excavated, and I'd love to do kind of more, you know, research, kind of learning about what they found there. I didn't dive too deep, but I'm sure that with some extra research, we can kind of learn about what was there and what their life was like prior to the eruption.
Great.
Thank you.
I have something that I'd like to ask. When you were talking about the wavy polar vortex, is that what's happening now with climate change and creating the unstable weather situations we see now?
That can happen under kind of what's happening now in terms of the increase in carbon dioxide, but it's also important to see that what's causing kind of a wavy polar vortex versus a more stable polar vortex happens kind of every few years. The Arctic oscillation, which drives that behavior, kind of goes back and forth between a positive and negative phase. So that's pretty normal. I would think that going forward in the future, with increases in carbon dioxide and heat trapping gases, you could have more increased swings in temperature over time. So you could have, you know, perhaps, well, what's going to happen, I should say, is that more likely we'll have more warm, kind of unexpected warm periods in the winter. I'm not so sure that we would have cold air outbreaks like what happened during Tambora period of 1816 during the middle of the summer. You know what I mean? So I don't know that the wavy polar vortex would necessarily lead to cold air outbreaks in the summer, but I would think that under a warming climate, we'd have more warm air outbreaks in the wintertime.
Thank you.
Oh, I see that question from Cindy. How did the other islands and people survive around Tambora? So there were some impacts, immediate impacts through ash fall and crop failures, and even immediately following the major eruption of tsunamis. So there were devastating impacts right around Sangar Peninsula and Sumbawa Island, where Tambora is located. But you also had, as I said too, the immediate after effect was 10,000 people losing their lives, but it is theorized that up to 100,000 people in the region were lost their lives because of this one event. So it might not have happened immediately, but through ashfall and through, essentially poisoning of water supply and of crop failure, you have a number of negative impacts just around that part of Indonesia.
Are there other questions? Okay. Well, thank you so much, Will. This was a really great presentation. I learned a lot. I can tell that you were definitely the education coordinator because you presented it so well, and it was really great.
Thank you so much. Thank you, everybody.
Thank
you. It's
you.
wonderful.
Thanks everyone for coming,
Very
and
interesting.
please feel free to fill out the event feedback form. The link is in the chat. We would definitely love to have your feedback so that we can bring you more great programs like this one tonight. Have a good night, everyone.
Thank you.
Good night, Will.
Bye, Will.
Bye.